Hello, today we're going to do Module 4, Lesson 11. And our objective is that we're going to demonstrate possible whole number side lengths of rectangles with areas of 24, 36, 48, or 72 square units using the associative property. Now, what do you remember about associative property? It's who you associate with is who you're friends with. So remember, we're going to switch around who they get to be friends with their parentheses. All right. Here we go. First, we start with an application problem. The restaurant's banquet table measures 3 feet by 6 feet. For a large party, workers at the restaurant place 2 banquet tables side by side to create one long table. Find the area of the new longer table. Okay, so first, we're going to draw a picture of the first one. Okay, sort of like a tape diagram. Here's the first one. This one is 6 feet long, and this is 3 feet long. Okay, now, let's suppose I put 2 together, side by side. Maybe they should have said end to end, because if you're going to make a really long one, you've got to put it by the end to end. Okay, now they're all the same. All the banquet tables at that restaurant are exactly the same. So I know that this would be 6 foot long. I know that this is going to be 3 feet long. Alright, so now we have to find the area of the new longer table. What do I need? Well, I know to find the area, I just need to have 2 sides. So, can I figure out what this side is? What would this side be? This would be 6 plus 6. 6 feet plus 6 feet equals 12 feet. So the whole length of this is 12 feet. Okay, now I know if I multiply it by 3, by this side, then I can find the area. So area equals 3 feet times 12 feet, right? Okay, now, let's see. 12 is kind of hard unless you have it memorized. So let's take 12 apart into something more manageable. So let's rewrite that as, instead of 3 times 12, let's do it, how about 10 is always easy. A 10 plus a 2. Okay, now, using the distributive property, I'm going to give the 3 to the 10, and I'm going to give the 3 to the 2. Okay, so here we go. So 3 times 10, it's 1 parenthesis, and then the 2, right? So 3 times 2. Okay, so now I've shared with everybody. Now I'm going to multiply, and then I'm going to add. So 3 times 10, oh, that's so easy. That's 30. Plus 3 times 2, what is that? That's 6, right? So my area equals 36 what? Square feet. And this is my answer. Okay. Now for our next problems, we're going to be using this problem with the 2 tables. Okay? So, another way, actually, before we do that, remember how lately I've been telling you that there's always another way to do it? Wonder if I could do it another way. Let's draw the picture again. I just don't want to forget this one way, because sometimes this one way is the easier way. And sometimes it might be your first way. Maybe that's how you see it first. You know that this side is 3 feet. You know that this side is 6 feet. Okay, so if I find the area of this rectangle and I add it to this area, I should be good, right? Okay, well, let's find that one. This one is 3 times 6. What is that? That is 18 square feet for 1. Okay, so if this is 18 and this is 18, let's add it up. Alright, so let's add 18 plus 18. Let's add it up. So 8 plus 8, my buddy isn't very clean. 8 plus 8 is 16. Alright, so 1, 2, 3 tens. I've got 36 square feet. Sometimes this is the easiest way to handle it. And either way, it's fine, right? They both came up with the same answer. Now, let's keep talking about these numbers. Okay? We're going to move on. Now this time, Okay. This time, we're going to talk about the fact that we had one long rectangle. This side was 3, and this was 12. And we know that 3 times 12 would give us the area. Okay. Now, let's do it another way. Still. Okay. So now let's break, instead of something like the 10 plus the 2, let's do it in a multiplication way. So what times what gives me 12? Well, 2 times 6 gives me 12, right? Okay, so let's put 2 times 6 in place of 12, and let's see what happens. Okay, 3 times 2 times 6. Okay, and what would we get? Well, this would be the associative property. They have the same signs, and if they have the same 2 signs, then we can move around the parentheses. They can be friends with somebody else, associate with somebody else, and we'll still get the correct answer. So let's do that. Instead of having them be friends with the last 2, let's have them be friends with the first 2. 3 times 2 times 6. So 3 times 2, what is that? That's 6 times 6. What's 6 times 6? 6 times 6 is 36 square feet. That's right. Okay, now, we've done it another way. Well, that's pretty good. We use the associative property this time. Now, what if we use the commutative property? Okay, so let's go over this way. Okay, so we have 3 times 2 times 6. Now, the commutative property says we can move around the order. It doesn't matter, and they will always be the same. We can do that with addition, and we can do that with multiplication. And the answer will still be correct. Okay, so let's move around the order. Alright? So, what if we do, what could we do? Well, let's see how I want to do this. Let's say, let's move it around. Let's change it around completely. Let's put the 2 times the 6 times the 3. That's commutative property for you. We can move it around any way we want. Alright, so let's see what we get. Now, where do we want our friends to be? Do we want to be around this way, or do we want to be around the first one? Well, I'm looking at this, and I think that I'm going to do it. Oh, let's see. Let's do it this way. Let's do it this way. Okay, well, what's 2 times 6? That would be 12 times 3. Oh dear. I'm going to have to come up with another thing for 12. Now, I found it this way. Is there anything else that would equal 12? Is there anything else that would equal 12? About 3 times something. What would that be? 3 times 4? Okay, let's try that. And let's put that right in here for 12. Okay, so let's do the 3 times the 4 instead of writing 12. Alright, and then we're going to multiply it by 3. Okay, now, that still leaves me with the same thing, so I need to use the associative property and change who it's friends with. Alright, so I'm also going to, if I move it over here, look what I have. This says 3 times 4. If I move it over, look what I have. I would have a 12 times 3 here. Well, I have the same problem here. I have 3 times 12 again. So let's really change it around. So let's use the commutative property and rearrange the order. So now let's do, how about 3 times 3 times 4? See, I have the same numbers, but I can rearrange them because of the commutative property. They can move around. Alright, now, I don't really want the 12, because 12 times 3 is what I had before. So if I put my parentheses here, I don't have 12 times 4, do I? I have 9 times 4. What's 9 times 4? Put all my A's back. What's 9 times 4? 9 times 4 is 36 square feet. Okay, now, oops, I have done so many different properties. I've done the distributive property. I've done in the last problem, the last page of the application problem, I have done the commutative property by changing it around. I've done the associative property by moving my parentheses. And I get the same answer. It's pretty handy, isn't it? Alright, let me just double check. I wonder if I can come up with any other way to get 36. I've had a 3 times a 12, okay, and I've had 6 times a 6, and I've had a 9 times a 4. Is there any other way that I could have 36 square feet so I would have the same area, just different sides of my rectangle? Well, this is a 3 by 12. I could make a 6 by 6. I could make a 9 by 4. What else could I make? Well, what equals 36? What equals 36? We haven't done a 1 by 36. Can we do a 1 by 36? Sure, we could do 1 by 36 feet. So 1 foot by 36 feet. It would be a very skinny table. You might lose your glass of water, but it would be very, very long, wouldn't it? All right. Now, I think we are good for today. Well, I do have one more question. Can I multiply anything by 5 to get 36? Well, what numbers, when you can't skip count by 5, do you end up with? Does any of them have a 6 at the end? 5, 10, 15, 20, 25. They all either end in a 0 or a 5, don't they? Well, this ends in a 6. Nope, can't use a 5. What about a 7? When I skip count by 7, do I come up with a 36? Now you end up with a 35. That's pretty close, but it's not the same, is it? But what about 8? Can I get close to 36? I can get close. I can get 32. 8 times 4 is 32, but then 8 times 5 is 40, so that goes over. So I can't have any sides with 8. Can I have anything with a double digit for a side? What if I wanted to try another side? I wanted it to equal 36. Can I do a double digit? What if I had, what's my smallest double digit that I've got? Well, that'd be 10, right? Can I multiply a 10 by a 10 and get 36? No, because the smallest I would get would be 100 if I multiply 2 double digits. So here's what you know about your multiplication facts to help you find the other sides you could possibly have for a rectangle. All right, I will see you soon. Good luck with your homework.